Welcome back. So B part to what we were just doing says to pick any 2 points from the line and find the slope. We did that already. I showed it to you on the line. I did the rate triangles. That's what these are called. The rate triangles. The only thing that I can think of doing extra with you is maybe picking 2 points on the line and doing it with the equation. So why don't we try that? Why don't we call this point 1? I'll call that point 1. Why don't we call this one point 2, just for fun? So I'm going to come over to the other side. I'm going to say that point 1, oh, I can't spell point, haha. You know what? Mathematicians would never write out the word point. They're going to do P1 to stand for point 1, and it's going to be negative 2 comma 8, and they're going to do P2 to represent point 2, and they're going to write it like that. And to be honest with you, I'm a mathematician. I don't like the words, so I'm going to use the notation. So for slope, so Fernando asked a great question. When do I use the formula? When do I use the graph? So I showed you how I used the graph. I counted over. I went down. In this case, if I was just given the coordinates, I would use slope equals the difference in y over, the difference in y over the difference in x. And I don't really see that as being two different formulas, Fernando, because I know that rise means vertical, and the vertical changes in the y's, right? And I know that run means horizontal, and that's the x's. So those aren't two different formulas to me. So what I'm going to do is I'm going to take x1 and y1, because these are from point 1, and I'm going to take x2 and y2, because these are from point 2. So y2 is negative 1, and y1 is 8. So negative 1 minus 8. x2 is 1. Subtract x1, and x1 is negative 2. So did you see that? The negative is from here. This negative and this negative are the same. And this negative 2 comes from this negative 2. So we've got a little bit of work of integers to do here. You know that a negative times a negative is a positive. So the top's going to be negative 1, subtract 8, which is negative 9, over top of 1 plus 2. So it's negative 9 over 3, and we have to reduce that. Let me get this out of the way. So 9 divided by 3 is 3, so it's going to be negative 3 over 1, which is the same that we got on the other side when we did it from the graph. So that's using the formula. Okay. And guys, you need to be able to do both. Example 4. Find the rate of change in earnings. So Abdul earns $12 an hour working at Home Hardware. Make a table of values showing Sam's total earnings for 5 hours of work. We can probably do this fairly easily. If Abdul doesn't work, how much does he make? Any idea? Nothing. If he works 1 hour, how much does he make? 12. If he works 2 hours, how much does he make? Okay. And then 36, and then 48, and then 60. Do we all agree? The equation for how much he makes is 12 times x. Does that make sense? So the number of hours he makes $12 an hour. What's the rate of change? Well, we can do this so quickly if we take a look at this and say, well, each one of these is going up by 1. And each one of these is going up by 12. So that means for every change in the x, we change 12 in the y. So the rate of change is really going to be, and I think I know what they want you to do here. They want way too much work here. They want us to do 12 subtract 0 equals 12. And here they want you to do 24 subtract 12 is 12. And here they'd like you to do 36 subtract 12. 36 subtract 24 is 12. 48 subtract 36 is 12. And I don't think we really needed to do that to see that it was going up by 12. But, you know, whatever. So the rate of change of Sam's earning is he earns $12 for every 1 hour. And the way you guys talk about that in real English is $12 per hour. But that's what that means. $12 per hour means $12 per 1 hour. I'm going to stop there and we'll do the last example in just a minute.